Hello and welcome. In this lesson, we'll explore the process of solving rational inequalities. It's a process very similar to solving polynomial inequalities, but unlike in polynomial inequalities, here we will notice the presence of a rational expression, which will slightly change the whole process of solving inequalities, rational inequalities. So let's get started with the first example. Here we have 2 over x minus 5 less than 10. Just like in polynomial inequalities, step number 1, take all the terms to one side of the inequality. So all terms to one side. And we want to leave just 0 on the other. It doesn't matter which side we pick. I usually prefer to take all the terms on the left side. So we have 2 over x minus 5 minus 10 less than 0. In the next step, step 2. If you remember from polynomial inequalities, we had to simplify. And we are doing something similar in here, but the process of simplifying when rational expressions are involved is slightly different. We want to combine both rational expressions. Notice that here you have a rational expression minus a number. Turn the number into a fraction and find the lowest common denominator. So we'll write in here simplify, and that will mean in this case combine all terms into a single rational expression. And here we go. Now we have a denominator of x minus 5 and 1. The lowest common denominator would be x minus 5, which means that 2 over x minus 5 won't have to change, but number 10 will have to multiply x minus 5. And now both terms will have or will be in rational form. Combine the terms together now that they have the same denominator. It shouldn't be a problem. So we have 2 minus. Now be very careful when we have a minus before a fraction. That will change the sign of every term into multiplication. You can think of this minus in here as if it belonged to 10. So minus 10 times x. That's minus 10x. And then minus 10 times negative 5, that would be plus 50, less than 0. One more step to simplify the numerator. So negative 10x plus 48 divided by x minus 5. And that must be less than 0. Now, once we have completely simplified the left side, which means that we have written the left side as a single rational expression, normally we will check for the factors of each numerator and denominator, and the purpose of it is to find the zeros of the numerator and denominator. So, next step, number 3, determine the zeros of the numerator and denominator. So I'm going to write both here, capitalized. So numerator and denominator. All right, so next step will look like this then. So we're going to take negative 10x plus 48 equals 0, which will happen at x equals 4.8. And in this case, I would leave the number in decimal form, the x value in decimal form, because I didn't have to round it. But normally, we would leave it in fraction form. And then we'll look into the 0 of the denominator, which is x minus 5 equals 0 at x equals 5. So here we go, we got both zeros. Now, let's take another look at this rational inequality and let's think together. What do we want to do with this expression? So what is the goal? We want to find the values of x that will make the rational expression that is on the left side negative. Now, I want you to think again about what would make this rational expression negative. So we are thinking, many things can happen. For example, if the numerator is negative and denominator is positive, then the division of the numerator by a denominator will be the division of a negative with a positive, so that would be negative. Or the other way around, so if the sign of the numerator is positive and denominator negative, then the division of a plus with a minus will give a negative number. So in other words, this becomes a matter of knowing what the sign of the numerator will be depending on the values of x and what the sign of the denominator will be depending on the value of x. And in order to find out for what values of x this will become negative, we will have to study the sign of both numerator and denominator. For this, I usually prefer to make a chart. And it's very useful, I would say, because it organizes the information in a clearer way. It makes a solution easier to understand even. So I would draw a t-chart first. This would be the number line. It represents the values of x from negative to positive infinity. And on the number line, I will be placing the zeros of this rational expression, which will be the zeros of the numerator and denominator. So 4.8 and 5 must be placed on the number line. And you do not have to actually scale it, obviously. We just have to put them in order as they appear on the number line. Now, here I'm going to write negative 10x plus 48. That's the numerator. And x minus 5. That's the denominator. The reason why I want to do this is because I'm studying the signs of each of them. Sorry about this, because I plan to write the steps in here, but then I think it was more efficient to write them on top. Okay, so here we are. We're going to draw one line at the bottom, and here we're going to write the sign of negative 10x plus 48 divided by x minus 5, because eventually that's what we want to find out, what the sign of the rational expression will be. Now, let's take another look at each factor. So negative 10x plus 48 will be 0 at x equals 4.8. When this happens, it means that the rational expression will be 0 divided by a number, which means that the rational expression will also have the value of 0. Positive 5, on the other hand, will make x minus 5 0, which means that if x equals 5, the denominator will be 0. And now we're thinking, if the denominator is 0, what's going to happen to the rational expression, to the value of rational expression? And we're going to say, well, that would be undefined. And now we're ready to study the sign of the numerator. One thing I want to bring your attention into is this negative sign. So the negative sign tells us that this is a linear expression, which if put on a graph will be going down. It will be represented by a line that goes down, which means that to the left of 4.8, the values of this expression will be positive, and after that, negative. You can discuss the sign, or you can decide on the sign of negative 10x plus 48, also by choosing testing values. For example, pick a number to the left of 4.8. for example, number 1, substitute it into negative 10x plus 48 and check and see what the sign of the whole expression is. So we have plus negative 10 times 1, negative 10 plus 48, 38. And for any number more than 4.8, say for example, a testing value of 6 will give negative 60 plus 48, so negative 10 times 6 plus 48, a negative value. Now, we have to discuss the sign of x minus 5 as well. So x minus 5 will be negative to the left of 5 and positive to the right of 5. Again, you can use testing values for it as well. Now, when we discuss the sign of the rational expression, we're basically working with these expressions. And we know that from negative infinity to 4.8, this expression will have the numerator positive, the denominator negative. That means that the rational expression itself will have the sign determined by the division of a negative, positive with a negative, which tells us that the rational expression itself will have a negative sign, so it will be negative. So for the next x values between 4.8 and 5, the numerator will be negative, and the denominator will also be negative. So that tells us that the rational expression will have the sign determined by the numerator, which is negative, divided by the denominator, which is also negative, and that will give a positive value. And last but not least, we reason in the same way for the next set of x values. So we have from 5 to infinity. The rational expression will have the numerator negative, the denominator positive. So what we have in here is a negative divided by a positive, which will give a negative. So now let's take another look at the question or at our inequality. So what we are looking for was the values of x that made the rational expression negative. And now we are thinking, where is the rational expression negative? So it is right here and right here. For what values of x does this occur? Right? Well, it happens when x is from negative infinity to 4.8, and when x is from 5 to 8. So these are the x values. Now, do we want the rational expression to be 0? So we're going to think, okay, so let's take a look at this. That says just less than, so not equal to 0, which means that 4.8 and 5 must be left out of the solution, outside the solution. 5 obviously is a value of x that makes the expression undefined, so no matter what, it will be outside the solution. And we'll say that the solution in this case would be the interval from negative infinity 4.8 joined by the interval 5 to infinity. And voila, we're done. Now let's take a look at another example. And if you feel ready, try to do this on your own. Example number 2. In the next example, we have a rational expression, x squared minus x minus 12 divided by x squared plus x minus 12, bigger than or equal to 0. As you can see in here, unlike in the previous example where we had to take the terms to one side of the equation, of the inequality to be more precise, and that's because we had terms on both sides of the inequality, we have to skip because we don't have another term here. So we're going to move on to the next step. So we will determine the zeros of the numerator and the zeros of the denominator. So I'm going to write the steps for this particular inequality here. And we have to be flexible when we determine what steps to follow or what steps to choose to follow when we solve any problem. because even when we're solving a similar group of problems, like we have to use our intuition to kind of understand what would be the first step, so what has more priority than others. So in step 1 in here, we will be the zeros, because this is simplified. All terms are in one side of the inequality. So zeros of denominator and numerator. So remember that to find the zeros of a quadratic expression, we're going to need to factor, if possible. Not all quadratics are factorable. So two numbers that add to -1 and multiply to -12 would be -4 and +3. And then we have to find the two factors of the denominator. So I will start with an x, because we have x squared. That's where this comes from. And we need to find two numbers that this time add to +1 and multiply to -12. So the two numbers that add to 1 and multiply to -12 are x plus 4, x minus 3, bigger than or equal to 0. So now it's easier for us to list the zeros. We have several factors here. So we have the numerator and the denominator. So for the numerator, we have the zeros at x equals 4 and at x equals -3. And for the denominator, we'll have the zeros at x equals -4 and x equals +3. So we're going to build the table so we can study the sign of this rational expression. Now, remember, I'm going to make the line a little longer here vertically, because I have to host 1, 2, 3, 4 factors. So we are trying to find the sign of x minus 4, the sign of x plus 3, the sign of x plus 4, and the sign of x minus 3. And down here at the bottom, we are going to try to determine the sign of the whole thing, which is x minus 4, x plus 3, divided by x plus 4, x minus 3. So you see the process is similar. Now, here is my number line, and what I'm going to do is place the zeros on it. Zeros of numerator and denominator. Don't forget, here we have positive and negative infinity. And the zeros must be listed from left to right. So we have the smallest number, -4. And then we have -3, and then +3, and then +4. So I'm going to give the 0 to each factor first. So -4 will be the 0 of x plus 4. And x plus 4, remember, is in the denominator. That means that will make the expression undefined. Moving on to x equals -3. -3 is a 0 in the numerator. And the 0 of the numerator will make the whole expression 0. Moving on to x equals 3. X equals 3 is a 0 in the denominator. So that would be the 0 of x minus 3. And the 0 in the denominator will make the rational expression undefined. And last but not least, x equals 4, which is the 0 of x minus 4, which is in the numerator. And that will make also the rational expression equal to 0. And now we have to decide on the signs of each factor. It's kind of easy if we recognize the patterns that all the leading coefficients here are positive, which means that to the left of the 0, the sign of x minus 4 will be negative, for example, after it positive. Why? Because all these lines in here are lines that are going up. And once a line hits the 0, it will become positive, right? As you go left to right. So that will make my job easier when I decide on the sign. So we're going to go negative and then positive. Obviously, you can always use the testing values as well. X plus 3 is in the numerator. So that means we have negative, and then after the 0, positive. X plus 4 will have the 0 at negative 4. So negative to the left, and then once it passes the 0, positive. And then last but not least, we have for x minus 3, the 0 at 3. So negative everywhere, after 0, positive. So now we are going to combine all these signs. So what we have in here is a minus multiplied by a minus, which is dividing a minus multiplied by a minus. So we have all minuses in here, and that tells us that the sign of the product here would be positive. Next, we have minus times minus divided by plus times minus. So minus times minus is plus, numerator positive, denominator negative, so the division will be negative. Next, minus, minus, plus, plus, minus. So these two minuses will make a plus. That means that the answer will be, here will be positive. Next, we have minus and then plus, plus, plus. So therefore, negative. Last, we have all pluses, so positive. So these are the signs that this rational expression will have. So it will be positive in 3 spots, here, here, and here. So negative infinity to negative 4, negative 3, 3, and 4 to infinity. And it will be negative for x values from negative 4 to negative 3 and from 3 to 4. Now let's take a look at our inequality. So what we want is the rational expression to be positive. So our solutions will be in the positives. And positives will happen for these particular x values. Right? So we're going to say x must have the values between negative infinity, comma, negative 4. And I'm going to pause for a second here, and I'll think, okay, so do I want the rational expression to be 0? So according to this sign here, we have bigger than or equal to 0, so we needed 0. So we're going to think, okay, so the zeros are acceptable. Let's take a look at negative 4. Is negative 4 a 0 that we can use? They say, well, but that will make the denominator undefined. So that means that we're going to place round brackets in here. Now, when you use round brackets, means that negative 4 is not included, but anything to the left of it is. And then this will be joined by the interval between negative 3 and 3. So I'm going to write negative 3, 3 here. And I'm going to think, okay, so let's take a look at negative 3. Negative 3 will make the rational expression 0. So that's a number that I want to include in my solution. And that's why I draw these square brackets. Positive 3, on the other hand, will be a 0 for the denominator, which makes the rational expression undefined. So even though I'm looking for zeros, this time I'm going to leave 3 out. And the last interval will be the one from 4 to infinity. 4 can be included because it makes the rational expression 0. So we're going to say that's 4, comma, infinity, Remember, infinity always has round brackets. And there we go. This is the solution to the second inequality for today. Rational inequality, not just any inequality. All right, so let's move on to another example. And I would encourage you to do this on your own. I will continue with the solution in the meantime. So we have 1, 2, 3 terms in this inequality. All of them must go to one side. So x minus 2 minus 8 divided by x less than 0. Now, I'll make them all look like fractions. And in the next step, I'll make them all look like they have the same denominator, which means with the lowest common denominator of x, we'll have to multiply by x over 1, so x over x, and then 2 over 1 is multiplied by x over x. Now my expression looks different, but it still has the same value. X times x squared, minus 2 times x, 2x, minus 8, all this divided by x. And that was a funny looking x, less than 0. Now, I want you to pause for a second and think. I wonder if anyone is thinking of doing something with this x in here. Say, for example, simplifying, or if you ever thought in the process of solving a rational inequality, whether or not we could do the cross multiplication, just like we do in solving equations, right? Rational equations. Now, I want you to think this way. When you solve a rational inequality, what we are looking for is the sign of the rational inequality. The sign of the rational inequality is not determined by the numerator alone or denominator alone. It's determined by both signs, numerators and denominators. And that's why we want to keep the x, or the denominator in this case, right? And do not simplify. It's a very common mistake people make. And it's a very easy mistake to fix as well once we understand the reason why. So I hope that was clear enough. And now we are going to start studying the sign. I will factor the numerator because I can. If I couldn't, actually, I could have just used quadratic formula. That's totally fine as well. And we have minus 6 and plus 2 here divided by x. Now it's easier for me to find the zeros. So we have a 0 at 6. A 0 at negative 2, and a 0 at 0, which is the 0 of the denominator. Number line, here we come again. And here goes, oopsie. That wasn't supposed to happen. This is negative, and this is positive infinity. And here we have x equals negative 2, x equals 0, and x equals 6. And here are the factors whose signs we are studying. X minus 6, x plus 2, and x. Down here, I will write sign of the whole rational expression here, which is x minus 6, x plus 2 over x. So here we go again. We're going to say that the zeros of the numerator, which are x minus 6 here, we have a 0. And here we'll make the rational expression 0. And this one is in the numerator. We'll make the rational expression 0. X is in the denominator. It will make the rational expression undefined. So here we go again. We're going to say all the coefficients here are positive, which means to the left of the 0, we're going to see all negative values for the binomial, x minus 6. After that, positive. Same thing here, minus. After that, positive. Minus. After 0, positive. So we have 3 minuses working together here in multiplication / division. That will give a negative. 2 minuses will make a plus multiplied by a plus. That's positive. Now, 2 pluses make a plus, times a minus, negative. 3 pluses make a positive. There is no doubt about that. And now we are going to take a look at our inequality. We're looking for values of the rational expression being negative. So where are they negative again? So we're going to say, they're negative here and here. For what values of x is the rational expression negative? I'm going to say, well, it's negative for these x values here, negative infinity to negative 2, and it's also negative between 0 and 6. So we'll have to write the solution here from negative infinity, comma, negative 2, joined by 0, 6. We don't want the zeros because the inequality doesn't suggest that we find the values that make the rational expression 0. So we are done. This is the solution. So see, it's kind of fun too, right? Now, I have another example I wanted to go over with you. And this would be including 2 rational expressions, one in each side of the inequality. I'll make them look a little bit prettier here. So we have x plus 3 divided by x plus 1 bigger than or equal to x minus 2 divided by x minus 3. So again, just like we did in the previous examples, we will be taking all the terms to one side of the inequality. So we have x plus 3 over x plus 1 minus x minus 2 over x minus 3 bigger than or equal to 0. We need to find the lowest common denominator. It's kind of easy to find lowest common denominators in rational expressions. Whenever you see that denominators are completely different from each other, they have no other factors and no common factors, then lowest common denominator will be the product of the two. Which means that we're now going to take a look at x plus 3 over x plus 1, and we'll multiply it by x minus 3 over x minus 3. So that's the same as the lowest common denominator. And then minus x minus 2 over x minus 3 multiplied by, this time we'll have x plus 1, x plus 1. Don't forget, bigger than or equal to 0. Now the denominator is the same, so we can draw a long line with a lot of confidence. X plus 1, x minus 3. And numerator will have to expand. So we'll be expanding these two. And we'll be expanding these two. So x plus 3 times x minus 3 is the difference of cubes, x squared minus 9, if you remember. If not, you can simply use foiling. So you can go ahead and multiply. But I would say remembering the difference of squares formula would make the solution a little bit faster, the process of solving a bit faster. And now we have minus. And here we have x minus 2, x plus 1. So there is no formula we can use in here. So we're going to go ahead and FOIL. So x times x, x squared. X times 1 is 1x. And now we go negative 2 times x, negative 2x. And then negative 2 times 1, negative 1. So one more step. X plus 1, x minus 3 is in the denominator. Nothing happens here. And I want to add something else to it. Never expand this. You want it in factored form because remember what the next step will be. We will have to find the zeros of the denominator. It's easier to find the zeros when denominator is in factored form. So we have x squared minus 9. And notice how here I purposely put brackets around the expanded form of x minus 2, x plus 1. And that is because there is a minus before the fractions. And when this happens, it means that everything that will be in this numerator will be entitled to this minus, right? So it will have this minus in front of it that will multiply it. So minus x squared. I'm going to skip a small step in here. X minus 2x is negative x. Move it outside the brackets. Positive x. And then plus 1. Last step, everyone. And we go the 2x squared simplify. We have just x in the numerator minus 8. That turned out beautiful, actually. And denominator has x plus 1, x minus 3. And look what I've done here. Check and see if there is anything missing. It's a very common mistake that people make because we get so involved in the process of simplifying the rational inequality and so on, and we forget to write things in proper form. And I would love to say that I did this on purpose right now because I actually didn't. I totally forgot. But good thing that I always double check my work. And then I'm going to write in here bigger than or equal to 0. And now I'm going to say I'm ready to solve this inequality. Here go the zeros. X equals 8, x equals negative 1, and x equals positive 3. Number line, here we come again. I'm going to draw a long, long line and a long vertical line to host my 3 factors, which are x minus 8, x plus 1, x minus 3. Let me just focus this. So here goes negative infinity and positive infinity. The zeros are at negative 1, positive 3, positive 8. I'm going to draw a long line here for my rational expression, which is x minus 8 over x plus 1, x minus 3. So we are talking about the sign of each factor and the rational expression there. So here we go. Negative 1 is the 0 of x plus 1, which means that we're going to give a 0 here. And that will make the expression, rational expression, undefined. Positive 3 will be the 0 of x minus 3. So we're going to bring the 0 right here. Okay. Now, x minus 3 is also in the denominator. So sorry, undefined again for rational expression. X equals 8 will be the 0 of x minus 8. That's in the numerator. So we can say that will make the numerator 0 and it will make the rational expression 0. And now let's do the signs. I love it when the leading terms have positive coefficients because I know that to the left of 0, it's negative, and after that positive. So I always start with a negative, and once I hit 0, I switch to positive. Again, remember, when can I do this? So when do I start with negative, and then once I hit 0, continue with positive? Only when the coefficient of the leading term is positive, right? So positive 1 for x plus 1. Okay, and then positive. Now let's multiply or bring all these signs together. So minus, minus, a plus times a minus, so minus here. 2 minuses and a plus, a plus. A minus, 2 pluses, minus, and then plus. Bam, 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 bam. Here are the signs. So let's take a look at the question again. So what were we looking for? We're looking for the value of the rational expression here to be positive. Great. So positive, it was here and here, which means for values of x between negative 1, 3, and 8 to infinity. So I'll write here negative 1, 3, and 8 to infinity. And I will say that x must belong to some intervals here in between. So now I have to decide on what brackets to use around negative 1, 3, 8, and infinity. For infinity, I always know that it's round brackets. For negative 1, I have to check with the chart. At negative 1, the rational expression is undefined. That means negative 1 is not included around brackets. At x equals 3 will make the rational expression undefined. So we're going to say, oh, we don't want 3, x to be 3, because it will make the rational expression undefined. So we're done with round brackets here, joined by. Now 8 will make the numerator 0 and the rational expression 0. And we did want 0, we said. So we're going to say we're going to keep the 8. And we'll indicate it by using the square brackets. And voila, here is the last answer.